NEOs deemed harmful. These frightening objects could strike the Earth with the energy greater than all the nuclear weapons on our planet today. Such an impact could trigger mass extinction.
You wouldn't expect one to hit but every several hundred thousand or millions of years. But if one did hit, it could wipe out a fair fraction of the population. So they're very low probability events, but high consequence events.
If they hit the Earth, they would have global effects. I mean, not only would you wipe out a continent with really heavy shock waves, but the ejecta would be thrown up in the air and come down all around the planet. The atmosphere itself would get to 1,000 degrees or so, and all the vegetation all over the world where that happened would flash into flames.
Cataclysms could also occur with smaller objects. So Congress now asks NASA to locate all NEOs 500 feet in diameter, as wide as the Roman Colosseum. An object that big could decimate a metropolitan area or even a small state. And what worries scientists most is not the asteroids they've discovered, but the ones they have not yet found.
At any given time, there's about 24 objects for which we can't yet rule out an Earth impact.
Former astronaut Schweikert has taken the threat of NEOs one step further. He's appeared before Congress to request a special government agency be responsible for protecting the public from space rocks.
Today, we have the technology to stop near-Earth objects from impacting the Earth for the rest of history. I mean, we can literally now begin to reshape the local solar system so that our survival is enhanced. The question is, will we? Or will we go the way of the dinosaurs?
But Schweikert isn't waiting for NASA or Congress to solve the problem. He has his own plans to save the planet from the next asteroid impact. It's hard to believe the Earth has survived over 4.5 billion years, because since its infancy, the planet has taken a beating. Like a boxer, our world is under constant assault from asteroids that enter our orbit each year. But in the future, Earth could be knocked out. Former Apollo 9 astronaut Rusty Schweikert refuses to be bullied by asteroids. And now he's ready to defend Earth against these harmful rocks.
We've discovered that there are these near-Earth objects flying by us all the time. And we've gotten more and more capability to modify our environment to enhance our survival.
Schweikert is particularly concerned about an asteroid named 2004 MN4, better known as Apophis. This pockmarked rock, approximately 750 feet in diameter, swept near Earth in 2004. Now it's scheduled to pass dangerously close to our planet again on Friday the 13th in April 2029.
So in 2029, Apophis will come closer to us than our own communication satellites orbiting the Earth. It will be so close that people who are in the right place will be able to see Apophis go by the Earth with your naked eye. You won't even have to have binoculars. That's how close that asteroid is going to come.
Apophis has an over 99% chance of missing the Earth in 2029. But if Apophis passes the Earth at a distance of exactly 18,893 miles, it may pass through a gravitational keyhole, a narrow region in space a half-mile wide. If this happens, the Earth's gravity could upset Apophis and change its trajectory. It could cause it to return and hit Earth 7 years later, on April 13th, 2036.
The gravitational effect of the Earth will cause it to bend, cause the Apophis orbit to enlarge to precisely the size which 7 years later it will come around and hit the Earth.
At the present time, Apophis has a 1 in 45,000 chance of delivering a deadly blow in 2036. But even these odds have scientists placing bets.
It's one thing to know that there's maybe 1 chance in 45,000 that it's going to hit the Earth, but what you'd like to know, is there 1 chance in 100? Is there 1 chance in 10? Is the probability 1 that it's going to hit the Earth?
Schweikert believes we must regard Apophis as we would any natural disaster. He's even mapped out where Apophis might strike.
You have the date of the impact, the time of the impact, the orbital inclination, and you can make a map. And what that map shows is what I have called a path of risk that goes all the way across the planet. And I look at this and I see a high probability of impact and I say, whoa, you know, where might it hit?
According to Schweikert, Apophis could impact any point along this path of risk. It begins in western Siberia, cuts across and down the Pacific Ocean near California. Then it traverses Central America and finishes in Western Africa. Schweikert proposes a chilling scenario of where Apophis might strike. The asteroid could land in the Pacific Ocean off the coast of California with the force of over 1 million megatons of TNT. Such an impact would create a 5-mile wide, 9,000-foot deep crater in the water, which would unleash tsunamis. Relentless 50-foot waves would pound the coastline, resulting in unimaginable human loss.
An asteroid that's 1,000 feet in diameter, having it hit in the ocean is not a good deal. Hundreds of billions of dollars of damage from something like that.
Scientists are presently working on technologies to preempt such a cosmic strike. One idea involves blowing up an asteroid. But some feel this could compound the problem, sending several chunks of the asteroid in our direction instead of just one. Consequently, Schweikert's new mission is to change the orbit of asteroids that could impact Earth.
What you want to do is basically change the asteroid's orbit very, very slightly. You change its velocity by a 10,000th of a mile per hour so that it will miss the Earth instead of hitting it.
Rusty's colleagues have drafted conceptual designs of spacecraft that could deflect asteroids, particularly Apophis. One would tow harmful asteroids away from Earth. But instead of lassoing the rock like a bull in a rodeo, the tractor will hover in front of it and use gravity as a tow line.
If you park in front of an asteroid for a long enough period of time and you stay close enough to it but not touching it, you're going to increase its velocity. Or if you park behind it while it's moving along, you're going to slow it down very slightly. We can change the orbit of an asteroid if we know about it far enough ahead of time.
Although a space probe has landed on an asteroid in the past, the most challenging idea is launching a manned mission. Once landing on the rock, astronauts could mount a radio transponder to track its whereabouts.
You could just use a robotic mission to go to an asteroid, land, grab a sample, and bring it back. That's not that difficult. What you gain by a manned mission is they can react to interesting areas on the asteroid surface. They could go here, there, and they wouldn't have to rely on remote navigation.
Nicaraguan border.